Hello friends, I welcome you in lecture number 19 on relations. In this lecture also we are going to discuss two more new operations on relations. We will discuss both the operations one by one. First operation is called converse of a relation. If we have a relation R, then how to define converse of a relation, or another name is inverse of a relation. So suppose R is a relation from one set to another set, say from X to Y, then R is a subset of X cross Y. We know that a relation R from set X to set Y is a subset of the Cartesian product X cross Y. Now how converse of a relation is defined? So converse of a relation is denoted by R tilde, and it is a relation from Y to X. If R is a relation from X to Y, then converse of R is a relation from Y to X. That means it is a subset of the Cartesian product Y cross X. If R is a subset of X cross Y, then converse of R is a subset of Y cross X, and it is defined by this type of ordered pairs. Ordered pair BA such that ordered pair AB is in the relation R. This is nothing but converse of the relation R. So for converse, if we know that R is a relation from X to Y, then converse of R is obtained by interchanging the order of elements in the order pair AB which is present in R. Whatever ordered pairs are present in relation R, we have to interchange the order of those elements or components. So if AB is an element of R, then BA is an element of converse of R. In other words, AB belongs to R if and only if order pair BA belongs to converse of R. Or we can say that if A is related to B via relation R, then B is related to A via the converse of R, B R tilde A. So this is the way how converse of relation R is defined. It is also known as inverse of a relation. Converse of a relation is also known as inverse of a relation, and it is also denoted by R to the power -1, that is inverse of relation R. This is the definition of converse of a relation. Another definition is complement of a relation. So this is similar to the complement of a set which we have discussed in set theory. We know that relation is also a set. It is a subset of Cartesian product, and we know how to define complement of a set. So if R is a relation from X to Y, that is R is a subset of X cross Y, then complement of R is denoted by these different notations, R dash or sometimes R bar also, and it is defined as complement of R, that is X cross Y minus relation R, difference of X cross Y and relation R which is a subset of X cross Y. So here we will have those ordered pairs AB from Cartesian product X cross Y which are not present in the given relation. From X cross Y we will subtract or we will exclude all those ordered pairs which belong to the given relation R, and we will obtain complement of R. So definition is same which we have discussed in set theory. We are considering simply complement of a set. Here set is a relation which is a subset of X cross Y. So here I have written systematically both the definition. Converse of a relation or inverse of a relation. Given a relation R from X to Y, a relation R tilde from Y to X is called the converse of relation R, where the ordered pairs of converse R tilde are obtained by interchanging the members in each of the ordered pairs of given relation R. This means if X is in capital X, Y is in capital Y, and such that ordered pair XY is in capital R, then ordered pair YX is in converse of R. So here we are interchanging the members in each of the ordered pairs which are present in given relation R. R tilde is also called inverse of R and is denoted by this notation also. So R tilde or R inverse equal to ordered pair YX such that ordered pair XY belongs to R. And if we are taking converse of a converse of relation, then we will obtain our relation back. If I am taking converse of this relation, then again I have to interchange these two members and I will obtain the original relation. So we have this property, converse of a converse of relation is equal to relation R itself, or in this notation also. And the next definition is complement relation. Let R be a relation from set X to set Y. The complement relation denoted by R bar or RC or R dash is defined as consider all those ordered pairs from X cross Y such that ordered pair is not present in given relation R. This is simply difference of the sets X cross Y and relation R. We are considering universal relation minus given relation and we obtain the complement of the relation. We understand with the example. Suppose we have two sets denoted by capital A and capital B. Here members are numbers 1 and 2. Here members are alphabets A, B and C. And suppose R is a relation from A to B defined as R equal to order pair 1A, 1C, 2B, 2C. And it is clear that R is a subset of A cross B. So R is a relation from A to B. Here we can write down A cross B also. Suppose I am interested in the Cartesian product of these two sets, then first I fix 1 and I am changing the second members 1 comma A, 1 comma B, 1 comma C. Similarly I fix 2 and I write 2 comma A, 2 comma B, 2 comma C. And we have written one subset of this Cartesian product A cross B, which contains 1A, 1C, 2B and 2C. So this R is a relation from A to B because R is a subset of A cross B. And we have to find out converse of this relation R. So as I discussed, to write down the converse of a given relation, we have to interchange the members in each of the ordered pairs in a given relation. Here first order pair is 1 comma A. 1 comma A belongs to R, therefore in R tilde we have A comma 1. Similarly here if we interchange the order of members, we have C comma 1, then 2 comma B, then C comma 2. So by interchanging the order of members in each of the ordered pairs in a given relation, we obtain the converse of a relation. Here converse of relation is written as I discussed. Interchange the members in each ordered pairs in a given relation to write down the converse of the relation. And to write down the complement of a relation, we have to consider difference of A cross B and given relation. So we are already having A cross B. From A cross B I have to exclude those members which are present in R so that I can write down the complement of this relation R. So 1A is present in A cross B So it is not present in the complement of relation R. Similarly, 1C is not included, 2B and 2C. I have to exclude all these members from A cross B, and I will be able to write down complement of relation R, R dash or R bar. So that I have written here also. The complement relation is R bar equal to RC equal to A cross B minus given relation R. This is A cross B, and here I have written given relation R, and I have to exclude all these members, 1 comma A, then 1 comma C, 2 comma B and 2 comma C, and I am left with two ordered pairs, 1 comma B, 2 comma A, and this is my complement relation or complement of the given relation. So in this way we can decide the converse of a relation and complement of a relation. We have to remember that converse of a relation is obtained by interchanging the members in each of the ordered pairs in a given relation R. Converse of relation R is the collection of ordered pairs B, A such that AB belongs to R, and complement of relation is nothing but we have to exclude all those ordered pairs from Cartesian product which are present in given relation R. I have written another example also. Let capital R be the relation defined as R equal to ordered pair AB, where A divides B on the set of positive integers, that is on the set of natural numbers. So here we are given this subset of this n cross n, because this relation R contains all those ordered pairs AB where A divides B on the set of positive integers. So here I have infinite set as my relation. This R is a subset of n cross n. This set is infinite, and we have infinite number of ordered pairs such that A divides B or first member divides second member, and I have to decide that what is the converse of this relation and what is the complement of this relation. So for converse, suppose I am interested in the element of converse of a relation. Suppose AB is an element or member of converse of this relation R. Then we know that if AB is a member of converse of relation R, then BA is a member of given relation R. This is by definition of converse of a relation. Converse of a relation is obtained by interchanging the order of members in a given relation R. So suppose I am interested in the nature of elements in converse of a relation, then I start with arbitrary ordered pair in the converse of a relation. Then by definition, if AB is a member of R inverse, then BA must be a member of given relation R. Now how given relation is defined? Given relation contains all those ordered pairs in which first member divides second member. So here I have written A first and then B second member. So here condition is A divides B. If first element divides second element, then this ordered pair is a member of given relation R. So here B ordered pair BA comma ordered pair B comma A is a member of R. Therefore first member, that is first element, must divide second element. So this means B divides A. So I obtain this condition for an element to be in the converse of a relation. So we can write that R inverse equal to ordered pair AB, which is in n cross n, such that B divides A. And if order pair AB is present in R, then A divides B. Here order pair AB is present in R inverse, therefore B divides A. If AB belongs to R inverse, then order pair BA must be in R, and in R the condition is first element divides second element. Here first element is B, second element is A. This is the converse of a relation R. And for complement, we have to write down R bar or R dash or R complement. This is going to be n cross n minus given relation R. This means n cross n minus all those ordered pairs AB in n cross n such that A divides B. If A divides B, then order pair AB is a member of relation R. But we don't require all these ordered pairs AB for which this condition is satisfied. So we are writing all those ordered pairs AB in n cross n for which A does not divide B. A doesn't divide B. Complement of a relation means all those elements which are not present in given relation R. Now element AB is present in given relation R if A divides B. That means element AB is not present in R if A does not divide B. So collection of all those ordered pairs for which first element does not divide second element are in the complement of a given relation R. So in this way we can write down the converse and complement of a relation for infinite subset also. Here our set on which relations are defined is n cross n, which is infinite set. So whenever we have infinite set, our relation will be given in this form. We will be having some condition. So using that condition we can decide what is converse of a relation and complement of a relation. So in this lecture we have discussed two important definitions or operations. One operation is converse of a relation, that means all those ordered pairs BA for which ordered pair AB belongs to R. And second operation is complement of a relation, that means all those ordered pair AB for which ordered pair AB is not in given relation R. So this is all about this session. I hope you like it. Thanks for